Tonight, you're going to watch the sun go down once, the way it always has, the way every person before you has watched it disappear behind a single quiet horizon. Now imagine watching it go down twice. Not a sunset and then darkness. A sunset, then a strange gray twilight. Then a second sun, creeping toward the same horizon, casting long double shadows behind everything you own. The real answer to what that world would look like is far stranger than a pretty sky. It would rewrite your calendar, your climate, your shadows, and possibly the rhythm of your own body. This is not science fiction. It is one of the most common types of planetary system in the entire galaxy. Here is the reframe. You have grown up assuming a solar system with one star is the default. It is not. Binary and multiple star systems make up a huge share of the stars astronomers have cataloged. Most of what you know about sunrise, sunset, and seasons is really just one very specific, very lucky arrangement. Change the number of suns, and almost everything about a livable world changes with it. Start with the sky itself. If Earth orbited two suns the way a planet does, in a system where both stars are close together, you would not see two separate disks crawling across the sky most of the time. You would often see what looks like one impossibly bright light, because from far enough away, two nearby stars blur together into a single point of light, at least until you looked closely. But move the second star farther out, into a wider orbit, and the picture changes completely. Now you get two true separate suns, each casting its own light, each rising and setting on its own schedule. This is not just imagination. Astronomers have actually found a planet like this. In 2011, a team led by astronomer Lawrence Doyle used data from NASA's Kepler Space Telescope to confirm a planet called Kepler 16b, orbiting not one star, but two. The two suns in that system circle each other every few weeks, and the planet circles both of them together. Reporters immediately nicknamed it the Tatooine planet, after the fictional desert world with twin suns, except this one is real, confirmed, and sitting in our own galaxy right now. So what would your daily life actually look like under two suns? Depending on how the two stars are arranged, you could get days that never fully end. If one sun sets, just as the other is still climbing, twilight might stretch on for hours instead of minutes. Your body, tuned by millions of years of evolution to expect darkness at a fairly predictable time, would suddenly be working against a sky that refuses to commit to nightfall. Why does that matter so much? Because nearly every living system on Earth, plants, animals, and you, runs on an internal clock built around roughly 24 hours of light and dark. Scientists call this a circadian rhythm. It controls when you feel sleepy, when your body releases certain hormones, and even how well your immune system functions. Under two suns with staggered rise and set times, that rhythm could be stretched, doubled, or scrambled entirely, depending on the orbit. Here is where the science gets genuinely strange. Researcher Rory Barnes, an astronomer who studies the habitability of planets in binary star systems, has modeled what climates on these worlds might look like depending on how far apart the two stars are and how the planet orbits them. In some configurations, a planet could experience wildly uneven seasons, baking under both suns at once during part of its orbit, then plunging into a long, cold season when it swings farther from one or both stars. In other configurations, the two stars balance each other out almost perfectly, and the seasonal swings barely change at all. Climate scientist Siegfried Egel has run detailed simulations of these two-sun climates testing how atmosphere, ocean coverage, and orbital tilt interact with two separate heat sources instead of one. His models suggest that some circumbinary worlds, that is, planets orbiting both stars together, could actually maintain surprisingly stable temperatures as long as the two suns are close enough together and the planet orbits far enough out. In other setups, the same basic ingredients produce climate chaos, with temperature swings that would make Earth's harshest deserts and iciest poles look mild by comparison. So the twist is this: two suns does not automatically mean 2 times the heat or an unlivable inferno. The habitability of a two-sun world depends almost entirely on geometry, on distance, on the dance between the stars and the planet caught between them. Move the numbers slightly, and you get either a strange but stable world or a planet that swings between extremes no ecosystem could survive. Now picture your shadows. Under one sun, every shadow you cast points the same direction and shifts slowly and predictably throughout the day. Under two suns, you could cast two shadows at once, faint and overlapping, stretching in slightly different directions depending on where each star sits in the sky. Ancient sundials, the earliest tools humans built to track time using a single shadow, simply would not work the same way. You would need an entirely different system just to know what time of day it was, because day itself would no longer have one simple definition. Color would shift too. Not all stars burn the same shade of light. A star cooler than our sun glows more orange or red. A hotter star burns bluish-white. If Earth's second sun were a smaller, cooler star, which is actually the most common type of star in the galaxy, you might get an environment lit by a strange mix of warm gold and pale white light. At the same time, shadows tinted with two different colors, depending on which sun was casting them. Think about how much of human history was built around the assumption of one predictable light source. Ancient calendars, religious rituals, agricultural cycles, and even basic language for describing time, morning, noon, evening. All of it assumes a single sun, rising and setting once a day. Under two suns, your ancestors would have needed an entirely different vocabulary, an entirely different set of myths, an entirely different relationship with the sky, because the sky itself would never behave the same way twice. And this is the part that quietly changes how you should think about your own solar system. Earth, having exactly one sun, is not some universal rule of how planets work. It is one outcome among many, shaped by how our particular solar system happened to form billions of years ago. Somewhere out there, on a real, still unexplored world, some form of life might be adapting right now to double sunrises, staggered twilight, and shadows that never point quite the same way twice. Using a body clock, nothing like your own. You watch the sun go down once tonight, the way you always do, the way it has always felt like the only way a sunset could work. Now you know that somewhere else, on some other world orbiting two suns instead of one, someone or something might be watching the sky do something you have never seen. Not one familiar ending to the day, but two, layered together, in a sky that was never built around just you.